Okay, section 9.6, the law of cosines. This is the method number 2, had a little typo there, for solving triangles that are not right triangles. This is a very, very exciting section because it's our last one. That sounds good. All right, so the law of cosines is a little bit harder to prove than the law of sines. If you go back to section 9.5, you'll see that I proved the law of sines for you. So I'm not going to prove it. I'm just going to tell you what it is, and you're going to use it. So there's actually 3 different versions of the law of cosines. And so we have c squared equals a squared plus b squared minus 2ab cosine c. And then a squared equals b squared plus c squared minus 2bc cosine a. And finally, b squared equals a squared plus c squared minus 2ac cosine b. All right, students always see that and they get overwhelmed and say, wow, I'm never going to remember all of that. Well, let's look at it more carefully. Let's look at this first one. It starts with c squared equals a squared plus b squared. That's just our Pythagorean theorem, so we know that part. And then because we don't have a right triangle, there's a little correction factor, and that's minus 2ab cosine c. So notice you got the c here and the c there. Those match. And you got the a and the b and the a and the b. Then if you look at the other two, all we really do is move the letters around. If we have a here, we have big A there. And if A is here, we have B and C in the middle and B and C in the middle. And same thing here. If we got B here, we got big B there, A and C in the middle, A and C in the middle. So once you really know one of them, once you know the first one, you really know the other two. It's just a matter of moving the letters around. Okay, so the big difference between the law of sines and the law of cosines. The law of sines, you'll remember, in order to use it, we always needed to know a pair. What if you don't know a pair? What if you don't have a big A and a little a, or a big B and a little b? That's where the law of cosines comes into play. So here's an example. We have all 3 sides, but we don't know any angles. Okay, so in this situation, what you want to do is find one of the angles. The one you want to find is the biggest one. Always start finding the biggest angle, and we know that has to be C because little c is the biggest side. So I'm going to use c squared equals a squared plus b squared minus 2ab cosine c because I want to find big C. And I just plug all the numbers in. 12 squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times cosine C. So I grab my calculator. I'm going to do 12 squared. And I'm going to move the 5 squared and the 8 squared over. So I'm going to do minus 5 squared minus 8 squared. That's 55 equals 2 times 5 times 8 is 80. So this is, don't forget the minus sign, negative 80 cosine C. So to get the C all by itself, I divide by this negative 80, and then I do cosine inverse. So big C is 55 divided by negative 80, and cosine inverse is, let's call it 133 degrees. Now, I have some options. I could go ahead and use one of these other versions to find A or to find B. Or, now that I have big C, I have a pair. I have big C and little c. So now I could use the Pythagorean, not the Pythagorean theorem, sorry. I could use the law of sines. Now, traditionally, most people probably use the law of sines at this point. Although it would probably be better to use one of these just because we could use these and only use data that's given to us, not something we computed. But again, that's not the way most people do it. So I'm going to do it the way most people do it. I'm going to use the law of sines at this point. So I'm going to find big A, perhaps. I'll have sine of big A over 5 is sine of 133 degrees over 12. So let's see, that's 5 sine 133 divided by 12, and then do sine inverse. So A is 18 degrees. I'm going to go to the nearest degree on these. And then finally to find B, B is just 180 minus 133 minus 18. B is 29 degrees. B is the easy one to figure out. All right, so that's going to be very, very common with these problems. Typically, you'll do the law of cosines once, and then quite often after that, you'll use the law of sines. All right, so let's see what we have here. We have angle A, we have little b, and we have little c. Again, I notice I don't have a pair. That's okay. I can use, if I have big A, then I'm going to use the middle version. Slide it down so you can see what I'm looking at. The middle version here. If I have big A, I use this one, and that's going to let me find little a. So a squared is 10.5 squared plus 18.2 squared minus 2 times 10.5 times 18.2 cosine 46.5 degrees. And then it's all calculator work. Slide this in so you can see my calculator here. 10.5 squared plus 18.2 squared minus 2 times 10.5 times 18.2 times cosine of 46.5 degrees. That's a squared, so I take the square root. So A is, we're going to call that 13.4. All right, and now we're back to where we were before, where now we have a pair. I've got a little a and a big A. Now that I have a pair, I can use the law of sines. So I'm going to say sine of big C over 18.2 is sine of 46.5 degrees over 13.4. And you might be thinking, you know, the teacher has said multiple times that we shouldn't be using data that we figured out. But I also always say, if you can avoid it. In this case, we can't avoid it. We have to use this number. It's our only option, so we use it. So let's see, 18.2 sine of 46.5 divided by 13.4. And then do sine inverse. Let's call this 80.1. So big C is 80.1 degrees, which makes it easy to find big B. 180 minus 46.5 minus 80.1. Big B's got to be 53.4 degrees. All right, so once again, you see where we use the law of cosines once, and then traditionally we end up using the law of sines on these problems. All right, last one. Let's see. A fisherman leaves home port and heads 70 degrees west of due north. All right, I'm going to have to draw a picture here. So he heads 70 degrees west of due north. So he's going this way, where this is 70 degrees. He travels 30 miles and reaches Egg Island. The next day, he sails 10 degrees east of north for 50 miles. So now, this is north. This is north here still, parallel to that other green line. So now he's going 10 degrees east. So he's going this way. 10 degrees, and my picture is not drawn to scale. And he goes 50 miles. Reaching Forest Island. So Forest Island must be up here. Determine the distance between the fisherman's home port and Forest Island. And then determine the angle from Forest Island back to his home port. Okay, so it's looking for this distance. So I'm going to call that C, for lack of a better term. Let's see, what do we know? We know this angle inside of here. Do we know that? Maybe not. I was thinking it was 80 degrees, but it's not. That would be if that were horizontal. What do we know about the angles? Let's see, you got to think about this. Okay, so I think if we draw this line here, which is parallel to the x-axis, then we can say that this angle has to be 80 degrees because it would be 90 all the way there. And then, since this angle's 70 degrees, this angle is 20 degrees. And then we've got the alternating interior angles thing, so that's got to be 20 degrees. So this big angle has to be 100 degrees. All right, that was a little bit more complicated than most problems we've done, but that angle has to be 100 degrees. So notice what we have now. We have angle C. We're looking for little c, and we know little a and little b. So we can use, for part A, c squared equals a squared plus b squared minus 2ab cosine c. C squared is 30 squared plus 50 squared minus 2 times 30 times 50 times cosine 100 degrees. Alright, so calculator time. 30 squared plus 50 squared minus 2 times 30 times 50 cosine 100 degrees. Square root that answer. We get, let's call it 63 miles. Alright, kind of hard to see my picture, but what we want now is the angle from Forest Island back to the home port. So we're looking for, I guess it depends on how you want to measure it. We could consider this angle from the direction he was going, perhaps, would be a good answer. Well, we can figure that out. So I'm going to call that angle A. So I would have sine of angle A divided by 30 is sine of 100 degrees divided by the 63 I just figured out. So that would be 30 sine 100 divided by 63. Oops. Forgot to close my parentheses there. Divided by 63 and do sine inverse. So it's 30 degrees. So it's 30 degrees from the direction he was going. Might be an interesting question to ask. What angle is that from due north? I'm not sure right off the top of my head, and I'm just about out of time. So that might be something you want to consider on your own. All right, well, that finishes it. That's the end of the course. Congratulations, you made it.